everybody. Well, our last contestant for the heats today is from the Faculty of Science and Engineering, Tim.
Well, I'd like to thank my supervisors. I've got two here, and since we're supposed to tell everyone where they're from, or where they're at if they're not here, one's in America, and acknowledge them for all their help that they've given me throughout the 6 months or so that I've been around. Driving north on State Highway 1, you may have noticed this familiar but significant New Zealand landmark, the Fonterra Tarapa Dairy Factory. It's certainly not the aesthetics or the architecture that appeals to me, but rather the dairy factory represents the powerhouse sector of New Zealand exports. In 2010, dairy exports soared over $10 billion. But did you know 85% was milk powder? To produce the equivalent of 1 tanker of milk powder, 10 milk tankers are required. Removing the 87% of water in milk is energy intensive and requires the use of spray drying. This process involves drawing in cold air from outside and heating it up to 200 degrees. Inside the dryer, milk is sprayed and hot air blown past, instantly evaporating the water, creating dry powder. Hot moist air then exhausts at 80 degrees. My thesis proposes that radiators are used to recycle the energy from the hot exhaust air into the cold incoming air. Potential is there to cut dryer energy use by 20%, which for the Te Rapa factory alone would save up to $3 million annually. Sounds simple enough, so why doesn't it already happen? Well, a major reason is the exhaust air contains a little milk powder. In this hot, wet environment, milk powder becomes sticky, and it's increasing the chance of it attaching to surfaces. Radiators are no exception. Powder will stick. The radiator will experience a powder build-up and foul. Fouling invokes fears of blockages and unplanned shutdowns. Fouling can limit the amount of energy recycling. Fouling can become a hygiene problem and challenging to clean. The aim of my thesis is to investigate milk powder fouling of radiators, both experimentally and numerically. My thesis focuses on addressing questions in 3 areas. First, I'll seek to understand the mechanisms and under what conditions milk powder sticks to flat plates, tubes and fins. Second, I'll look at the impact milk powder fouling has on radiator performance, such as energy recycling and airflow resistance. Third, I'll develop a radiator model using advanced fluid engineering tools. I'll also confirm the results from my radiator model using my experimental results. These outcomes will help the dairy industry find design solutions that effectively negotiate the sticky end of spray dryer energy recycling. Thank you.